Hello, I'm Teacher Ivan from Wunna Educational Services. We are still continuing with our O-level physics revision questions and basically calculations. We are on our next lesson concerning density and relative density. Actually, we are winding up density so that we go to relative density. Currently, we are looking at the density of mixtures. We saw how we get density of mixtures in our previous video. We are just continuing with more 2 examples on how to get density of mixtures. So please, if at all you did not watch our previous lessons concerning density, just run to our playlist, go to O-level physics calculations, look for density lessons. We have lesson 1 up to the most recent. Watch so that we move together as we enjoy together. Now let's go to our third example. We have so far looked at 2 examples on how we get density of mixtures. We are going to our third and fourth examples, and we close up density and go to relative density. Our third example says that an alloy is formed. You know that alloy is a mixture of 2 or more metallic substances in most cases. So an alloy is formed by adding 500 grams of element P of density 5 grams per cubic centimeter to 400 cubic centimeters of element Q of density 4 grams per cubic centimeter. They want us to calculate the density of the alloy. Don't forget that density of the alloy, which is a mixture, is given by the mass of element P plus mass of element Q over the volume of P plus volume of Q. So let us summarize from the question. We are told that an alloy is formed by adding 500 grams of P. So that is mass of P, which is 500 grams, and the density of P is 5 grams per cubic centimeter. This is added to 400 cubic centimeters of Q, so that is volume of Q is 400 cubic centimeters, and the density of Q is given to us as 4 grams per cubic centimeter. This is the information given to us from the question. You realize that for element P, we are given mass and density, while for element Q, we are given volume and density. So in this we are lacking volume of P. In this we are lacking the mass of P. But that is so easy to us, since we know that density equals to mass over volume. This can help us get what we want. Let us start with P. If we consider element P, what do we need? We need the volume. So we make a volume the subject. That is, from this, we will multiply by V. That gives us V rho equaling to M. Since we want V, we divide by density, hence giving us the volume of P as mass of P over density of P. And good enough, we are given the mass of P and density of P. So we can find the volume of P as mass, which is 500 grams, over the density, which is 5 grams per cubic centimeter, hence giving us the volume of P as 100 centimeters cubed. So that is the volume of P. Now that we have volume of P and mass of P, we can get the density of the alloy. However, in the second element, which is 2, we have volume and density. We must get the mass of Q, so that we substitute in the formula for density of the alloy, which is mass of P, we have it, mass of Q is what we don't have. So still, from the same equation, we shall say from density equals to mass over volume. This time round we want the mass of Q, so we make M the subject by V by V. So we cancel this and that, hence ending up with M, which is the mass, equaling to V times rho. So meaning that mass of Q will be volume of Q times the density of Q. And good enough, we are given the volume of Q and density of Q. So when we multiply the two, that gives us the mass of Q as 400, which is cubic centimeter, times the 4 grams per cubic centimeter. The cubic centimeter will cancel with this, since this is per, meaning it is dividing. This one is cancel, and we end up with the mass of Q as 1,600 grams. So that will be the mass of Q. Now that we have the mass of Q, we can now go back to our formula for the density of the alloy, which is mass of P plus mass of Q over volume of P plus volume of Q. Mass of P is given to us in the question, which is 500 grams. The mass of Q is what we have just found, which is 1,600 grams, over volume of P was not given, but we found it. If we recall, we found it as 100 centimeters cubed plus the volume of Q, which is given as 400 centimeters cubed. So that gives us 2,100 over 400. This will be in grams per cubic centimeter. So we simplify that and come up with the density of the alloy. So that has been our third example. You see that in each of these examples, there is a new trick being introduced to us. So we shouldn't ignore the examples, but we should just watch, follow, so that we get the concept in each example. Let us go to example 4, which is our final example concerning density of mixtures. In example 4, we are given 3 cubic centimeters of water was mixed with 2 cubic centimeters of milk of density 1,500 kilograms per meter cubed. They want us to find the density of the mixture. So from the question, let us still summarize. In the question, we are given volume of the water as 3 cubic centimeters. We are given the volume of milk as 2 centimeters cubed. However, we are given the density of milk, which is 1,500 kilograms per meter cubed, but we are not given the density of water. However, it is known to be a constant. So the density of water is 1,000 kilograms per cubic meter. 2. The other thing you should look at critically is the difference in units. Our densities are in meters cubed, per meters cubed, whereas these ones are in centimeters cubed. So we must convert before we get the density of the mixture. We either convert the densities from kilograms per meter cubed to grams per cubic centimeter, or we convert the volumes from centimeter cubed to meter cubed. Any can work. I choose to convert the volumes. We know that 1 meter cubed is equivalent to 1 million centimeter cubed. Then that means that if I divide by 1 million on both sides, then that gives me 1 over 1 million meters cubed equaling to 1 centimeter cubed. So from this, it shows you that when I'm converting from centimeter cubed to meter cubed, I divide whatever I'm given by 1 million. And therefore, I would say 3 cubic centimeters equal to 3 over 1 million. This is meters cubed. So I'm converting from centimeter cubed to meter cubed, which gives me 3 exponent negative 6 meters cubed. Still, the same applies to the 2 cubic centimeter. This will now be 2 exponent negative 6 meters cubed. So I have converted the centimeter cubed to meter cubed. Now that they are having corresponding units, I can now continue. So I have new units of volume. Volume of water is now 3 exponent negative 6 meters cubed, whereas that of milk is 2 exponent negative 6 meters cubed. The density of water is 1,000 kilogram per meter cubed, whereas that of milk is given the question as 1,500 kilograms per meter cubed. So I have volumes and corresponding densities. The question is asking for density of the mixture. We know that density of mixture is given by the mass of water plus mass of milk over volume of water plus volume of milk. But since I'm not having the masses, I will express the mass in terms of density and the volume. That is, from volume equals to mass over density, then that means that when I multiply throughout by volume, I'll end up with the mass being equivalent to volume times density. So where I have mass, I can replace it with this. And therefore, I will have density of the mixture as where I have mass of water, I will say volume of water times density of water, plus volume of milk times density of milk, over volume of water plus volume of milk. So that's how I will use volume and density to stand for the masses. And now that I have everything I need, I will just substitute. So the volume of water, we saw 3 exponent negative 6. This was meters cubed times the density, which is 1000, plus volume of milk was 2 exponent negative 6 times the density, which is 1500, over the volumes, which is 3 exponent negative 6 plus 2 exponent negative 6. So that is what I have to manipulate with my calculator, simplify to the final density of the mixture. That means that our final density of mixture will be still in kilograms per meter cubed. So that has been density of mixture. Please don't forget to subscribe to all our YouTube channels. Just to go to the home page, scroll down, you will see those featured channels. Subscribe to them, hit the bell so that you get notified whenever we have updates on our channels. We have Facebook groups and pages in the same names. Please search for them, follow and join them, so that we make your learning convenient, easy, possible, and enjoyable. We are on Twitter in the names of Wuuna Edu Services. We are on TikTok in the name of Wuuna Educational Services. We are on Instagram in the names of Wuuna Educational Services. We are on WhatsApp and so many other platforms. Just search for Wuuna Educational Services. Join us, like us, share our content, and please don't forget to subscribe to all our channels. Thank you. I'm Teacher Ivan. Hope to see you for the next lesson. Bye bye.